Okay everyone, so first I'm going to show you how to make the foldable in case you did not have a chance to do that in class. So the first thing you're going to do is take the paper that you picked up at the door today and you're going to trim around the edges. So you're just going to cut around the edges. You don't have to cut exactly on the line because the two sides don't exactly match up. So just kind of trim around those lines, trim around the edge. Okay, so here's the foldable. And actually what we're going to do is we are going to flip it over. So you should flip it over to the side that has more information on it. And you are going to turn it sideways and fold the edges so that they meet in the middle. Okay, they should not overlap. They should touch each other. The edges should touch in the middle of the foldable. And then you go ahead, fold your creases there. Okay. And this is what it looks like once it's been folded. Now what you have to do is cut on these lines on the flaps to cut the different types of reactions away from each other. So the finished foldable should look like this, okay? And you should have 2 larger flaps on the top and 4 smaller flaps on the bottom. Okay everybody, so what we're going to do today is talk about the 6 types of reactions. By the end of this lesson, you guys should be able to look at an equation and determine which of these 6 types it is. Okay, you should be able to classify equations by type. So first off, I want to talk about the categories we have for our types of reactions. So you'll notice 2 of them say double replacement, and the other 4 say oxidation reduction. So let's talk about double replacement real quick. In a double replacement reaction, what we have is 2 compounds. So 2 ionic compounds. They switch cations. So the positive on each one switches, okay? So at the end, what you get is A with Y and B with X. So both of these types of equations kind of follow that recipe. We've got 2 ionic compounds, they switch cations, and we end up with 2 ionic compounds as products, okay? So the first type of double replacement that I want to look at is a double replacement reaction that occurs with acids and bases, okay? Acid-base neutralization is going to be our first type of equation. It's called acid-base neutralization. We talked about pH a little bit when we talked about naming acids. We know that acids have a pH lower than 7. Bases have a pH greater than 7. When we put them together, they form water, which is neutral. So an acid-base neutralization reaction is where we're putting together an acid. So notice one of your reactants is going to start with hydrogen. It's going to be an acid. We're also going to have a base. So one of your reactants is going to have hydroxide. When we switch the cations, so when a hydrogen and this cation here switch, we end up with AB, which we're going to call salt. And the other product, because it's going to be the hydrogen and the hydroxide that form this product, the other product is always water. So water is always going to end up as a product in our acid-base neutralization reactions. And since water is neutral, that's where it gets the name neutralization, okay? So you have acid, base, water, okay? Ionic compound acid, ionic compound base, ionic compound known as a salt, and water, okay? The other type of double replacement reaction, the other one where we have 2 ionic compounds that switch cations, is known as a precipitation reaction, okay? So in a precipitation reaction, we have 2 ionic compounds, they switch cations. We don't always get water. There's not anything we can recognize that's always going to be in this equation, but what does always happen is a solid always forms. So in precipitation reactions, we're going to take 2 solutions And since these solutions are compounds dissolved in water, we call them aqueous solutions. That's what the AQ stands for right here. So we're taking two aqueous solutions. These compounds are dissolved in water, so they look like liquid, right? We're taking two aqueous solutions, and when we put them together, we end up with one solid compound. You'll notice a solid form. That's called a precipitate. And then there's one aqueous product. Okay, so in a precipitation reaction, we put together two things that are dissolved liquids, and we end up with something that's solid at the end. So when we're actually doing chemical experiments, these are kind of easy to spot because you put together two liquids and you see this chunky solid starting to form. When we put the state symbols in our chemical equation, when we identify aqueous, aqueous, solid, aqueous, we could see that there was a change in phase here. We can see that a solid formed. So if we have those state symbols in our chemical equations, it makes it pretty easy to spot these precipitation reactions, okay? All right, so then the other type of equation that we have, the other category, I guess, is oxidation reduction. So there are four types of oxidation reduction equations. First off, what is oxidation reduction? Okay. So in oxidation reduction reactions, what ends up happening is electrons move from one element to another, causing a change in oxidation state. Okay, so in these types of equations, the electrons are also moving. So it's not just that the elements themselves are rearranging, but the electrons are actually moving from one place to another. So the oxidation states, aka the charges of the elements, is changing during these reactions. Okay, so there's a way to remember what's being oxidized and what's being reduced. Oxidation is losing electrons. I'm going to abbreviate electron with E minus. Okay, so when something is oxidized, it loses electrons. And when things lose electrons, they become more positive. So whichever thing is becoming more positive because it's losing electrons is being oxidized. Now, where are those electrons going? If electrons are being lost, they have to be gained by something else. So something else in the chemical equation is going to be reduced. Reduction is gaining electrons. And when something gains electrons, it becomes a negative ion. Okay, it becomes more negatively charged. So we can look at the types of equations and we could determine what's being oxidized and what's being reduced. We'll do that at a later time, okay? For now, what I want you guys to be able to do is recognize the types of equations. So the four types of equations in which the oxidation states are changing are going to be single replacement, combustion, composition, and decomposition. Okay, those are going to be the four types of equations in which charges of the elements is changing. By the way, in double replacement reactions, there is no change in oxidation state. So that's why they're a separate category. In double replacement reactions, they're just swapping partners. The ionic compounds are simply switching partners. In oxidation reduction reactions, the charges are actually changing, so it's a little bit different. That's why we have two categories here. So the first type that I want to look at is single replacement. Okay? In a single replacement reaction, you're always going to notice an element and a compound as reactants. And at the end, you have a compound and an element, but it's not the same element. So what happens is A and B swap places. So this element replaces one of the elements in the compound. And so now A is with X and B is by itself. Okay? The second type of reaction is a combustion reaction. So you might recognize that word combustion. Combustion is burning. And so these equations are the equations for burning hydrocarbons. Okay, what is a hydrocarbon? Well, that's really easy. Anything that is simply made of carbon and hydrogen is a hydrocarbon. Notice that there are number signs here because the only difference in these types of equations is the numbers that make up the subscripts here. Okay, sometimes it's a carbohydrate that we put here, so sometimes there's some oxygen in this compound as well with the carbon and hydrogen. But anytime you have carbon and hydrogen together, plus O2, because oxygen is necessary for burning, this is combustion, our two products are going to be CO2 and H2O. So these equations look almost identical. The only difference is the numbers in this hydrocarbon, and then of course the coefficients that we use to balance the equation. But there's always some hydrocarbon plus O2, oxygen, remember oxygen is one of the diatomic elements, yields CO2 plus H2O. So it's almost exactly the same for all of these, okay? The last two are kind of easy to spot, okay? The first one is a composition reaction. So in composition reactions, you take two things, you put them together to compose a new substance. Okay, so composition is when you make something. So we're taking two things, usually two elements, and we're putting them together to make a single product. So anytime you start with two things, but you end up with one, that is going to be a composition reaction. These actually have another name. Sometimes they're called synthesis reactions. So go ahead and write the word synthesis right there. So that you know that those two things mean the same thing. Okay, so composition reactions, aka synthesis reactions, are where we take two reactants and put them together to form a single product. So then decomposition is exactly the opposite. Decomposition in chemistry is kind of like it is in biology. We're breaking something down. So in decomposition chemical reactions, you start off with a single reactant and it breaks down into two simple products. There could even be three simple products, but it breaks down into simpler substances. So anytime we start with a single thing and we break it apart into multiple parts, that is going to be a decomposition reaction, okay? Now later on we'll talk about how the charges change in these chemical reactions, but for now you guys have to be able to classify the reactions. So what I have are the station cards from the stations activity that we did in class. And I want you guys to be able to recognize the type of equation. So if we look at station 1, these were the equations from station 1. And so if we look at it, in each one of these, I see Al plus O2, we end up with a single product. I take two elements, I put it together, I get a single product. Here we put together three things. We put nitrogen, oxygen, and water together, and we ended up with nitric acid at the end. But we were taking a bunch of things and putting it together to make one product. So when we're taking multiple substances and combining them to form a single product, what type of equation is that? That's going to be a composition reaction. Okay, so in composition reactions, we take two or more simple substances and combine them to form a product. Okay? All right. At station 2, you'll notice that we had an element and a compound, and then two of the elements switch places. So there's a new element in this compound and a new element that's by itself. Okay? Here we have tin 4 oxide and hydrogen gas. Again, hydrogen is one of those diatomic elements. It's H2. So when it's hydrogen by itself, it's not really by itself. It's H2. And so hydrogen switches places and bonds with oxygen to form water, and then tin is by itself. So I have a compound and an element, and then two of the elements switch places, and now I have a new compound and a new element by itself at the end. Okay? So what type of reaction is that where we have an element and a compound, and they two of the elements switch places, and I have a new compound and element at the end? It's going to be single replacement. Okay, so I have a single element by itself and a compound. They switch places. I end up with a new compound and a new element by itself. Okay, so station 2 is single replacement. Okay. At station 3, we started off with this single reactant, and it broke down into simple products. Okay, so a single reactant breaks down into multiple products. Here, this NH4NO3 ammonium nitrate, this broke down into nitrogen gas, again diatomic, oxygen, diatomic, and water. So if it's breaking down into simple substances, these are going to be decomposition reactions. We start off with one thing and we end up with multiple products. Okay, nobody likes station 4 because this one was tough to balance, right? But you should have noticed a lot of the same. You notice that one of the elements is an acid. It starts with hydrogen. One of the elements is a base. It ends with hydroxide. And one of the products is always water. If you look, water is a product in every single one of these equations. So if I have an acid and a base, and they are reacting to form water, then that's going to be an acid-base neutralization reaction, okay? So acid starts with H, base ends with OH, the H from the acid and the OH from the base combine to form water, which is then neutral. So this is a neutralization reaction, okay? At station 5, you'll notice that it looks like I just cut and paste all of these problems. I might have, I don't know. All I did was change these numbers on the hydrocarbon. So I end up with C something H something plus oxygen O2 forms CO2 plus H2O. The only difference is the numbers here. And again, I told you guys that sometimes there could be oxygen in the hydrocarbon, so it becomes a carbohydrate. Okay, so, but it's still the same elements, right? Carbon, hydrogen, oxygen, O2, CO2, H2O. And so that type of reaction that almost looks identical all the time is going to be a combustion reaction, right? We have the hydrocarbon and O2, oxygen, form CO2 and H2O. And then at station 6, what we had two compounds at the beginning, and then the first element on each switch places. Now notice that they don't keep their original subscript. So like B2 didn't stay B2 over here because it was combining with something with a different charge. So we have boron with bromine, but then we switch, and now boron is with nitrate and hydrogen is with bromine. So ionic compound, we're switching those elements. Ionic compound, we're switching those elements. I don't see any acid-based water, right? There's no acids in here. Water is not a product in any of these. So if it's two ionic compounds, we're switching the positive ions. We're forming two more ionic compounds. These are going to be precipitation reactions, okay? So I have two aqueous compounds, and there were no state symbols in here, so it's kind of difficult to tell. But if I have two ionic compounds and I see that they're switching partners and it's not acid-base neutralization, then I guess the only other option is that it's precipitation. Okay, if I have two ionic compounds and I switch those elements on the front to form two new ionic compounds, then that's going to be an a precipitation reaction. Okay. So make sure that you guys have the information that I wrote on the foldable on your foldable for tomorrow, because we will be identifying equations in class.